This is section 6.2, part 5. We're at our hardest problems here. Okay, so I want to factor 3t cubed plus 27t squared plus 24t. In this course, if you have a number in front of your largest exponent, you either have a greatest common factor or you might have one of the special forms we talk about in the next section. You always need to look at something, okay? The other clue that we might have something else going on is I have a cube here. And we generally know how to deal, when we have 3 terms, we're going to be dealing with squares most often. Remember, your first step is to look for a greatest common factor. I have a 3, I have a 27, and I have a 24. 3 divides evenly into all of those, so I'm going to factor out at least a 3. All of these have a t on it, so I'm going to factor out a t, and then I take the smallest variable on that t. Our smallest variable here is a 1, so I factor that out. This is to the first power. Now when I do this, from here I get a t squared, because 3t times t squared gives me 3t cubed, plus 3 times 9 gives me 27, t times t gives me t squared, plus 3 times 8 gives me the 24, and then there's the t. Okay? So at this point, this is already not prime. We were able to factor out a GCF, so it is not prime. We don't know if we're factored completely or not. So I need to look at this like it's a separate problem. And I'm going to see if I can factor this any further. This is what some teachers call a traveler. It's going to follow us down. We can't lose it, but we don't really have to worry about it again. If I look at this, make sure that you really did factor out the largest thing possible. If all you saw was the 3 when you factored out the GCF, you should be able to catch that you missed the t here, or vice versa. If you saw you could factor out the t, you should probably catch that you could also factor out the 3 here. Look here though, I'm looking for 2 numbers that multiply to a positive 8 and add to a 9. Things that multiply to 8, 1 and 8, 2 and 4. I need to multiply to a positive number so they have the same signs. 1 and 8 add to positive 9. So this comes down 3t times, my variable is t, plus 2. I don't have an extra variable in here, so I don't have to worry about that like I did before. Close that, and then t plus 4. You always want to look and make sure you've got everything as nice and neat as possible, and you do. That is your answer. Okay, so let's try this one too. I see I have a number in front, so I'm really hoping I have a GCF, and all of these are even numbers, so I definitely do. I don't have a variable in common with all of them, so the best I can do is I can factor out a 2. And that gives me x squared plus 13x plus 36. Now the 2 is part of my answer. It's definitely not prime because I could factor out the 2. Now I just need to see if this factors any further. I'd be looking for 2 numbers that multiply to a 36 and add to a 13. Now never mind. 2 numbers that multiply to 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Multiplying to a positive, so they need to have the same signs, add to a 13, 4 and 9 work. So this 2 travels down, follows us along. My variable is x, positive 4, times x, positive 9, plus 9. Okay, so let's look at our last problem. negative b squared plus 7ba plus 18a squared. Okay, on the first page, one of the things I said was that, first of all, we technically don't know how to deal with it when you have a number other than 1 in front of your x squared. But in general, even after you know how to do that, it's always easier if your first number is positive. Okay? And all we have to do is to factor out a -1 to make that happen. So what I'm going to do here is I look for GCF, and I really don't have anything other than a 1. There's nothing else that's in common. So I'm going to factor out this -1, and what this does is it changes all of the signs in here. B squared, it's now minus 7ba minus 18a squared. I'm going to go ahead and circle this extra variable in here to help me remember it. Okay, we factored out a -1, but we often just say we factored out a negative because mathematicians are lazy, and if there's a way we can shorten things, we do. So let's look at this. I want two numbers that multiply to a -18 and add to a -7. Things that multiply to 18. 1 and 18. 2 and 9. 3 and 6. Now I'm supposed to multiply to a -18, so that means one of these is positive. -7, I can get that from the 2 and the 9. If I make the 9 a negative number, that gives me the -7 when I add them. It gives me the -18 when I multiply them. Now I'm going to bring this down just as a negative. You can keep the 1 there if you want to, but you can't lose it. My variable is b plus 2, don't forget the a, times b minus 9a. And all of this would be your answer.